All right, moving on to problem 20. In our chapter review, we have negative 17 and 1/4 plus negative 7 and 5/12. All right, now I've written it in the vertical format just in case in a problem we end up needing to borrow and all that when we're doing the renaming. It makes it a lot easier than if we've written it horizontal. So I've written it in the vertical format, and we can see that we do need to rename with new denominators, right? Because we need both of our fractions to have the same denominator. So I recognize that I can rename this first fraction and make it a 12. I'm going to take this first fraction and multiply by 3. And when I do that, I'm going to get 3 over 12. So now I have negative 17 and 3/12. And then I have negative 7 and 5/12. And I'm going to combine these two negatives together. Remember our rules. They have the same sign. So I need to add them together. Even though that looks like a subtraction sign to me, I'm going to do some addition. So I'm going to start with my fractions. 3 and 5 will make 8/12. And then I'm going to add my whole numbers. And I'll get 24. And my answer is going to carry the sign of the numbers that I combined together. They were negative, so my answer is going to be negative. And then I want to rename this. I can divide 8 and 12 by 4 and get lowest terms, and I'll end up with negative 24 and 2/3 for my final answer. Again, this was problem number 20. Now in the next section, we're finding the product of fractions. So that the word product tells me to multiply. So I am multiplying fractions together. Let's look at problem 25. Problem number 25. I have 4 times 5/7, and I'm going to multiply that by 7/8. So I'm multiplying 4 times 5 over 7, and then I'm going to multiply that answer times 7 over 8. So I want to start here. I'm going to rename my 4 as 4 over 1 times 5 over 7. I don't see any opportunities for cancellation here, so I'll multiply my numerators and get 20, multiply my denominators and get 7, and now I'm going to multiply this times 7 over 8. And here I do have an opportunity to cancel here and again here. Both 8 and 20 can be divided by 4. That gives me 2 and 5. And so when I multiply my numerators, I get 5. My denominators, I get 2. And I'll rename as a mixed number. 2 goes into 5 2 times. 2 times 2 is 4. 4 and 5. 1 left over. So I have 2 1/2 as my answer. And problem 26. It's going to be very similar. I've got some mixed numbers though, and I need to start off by renaming my mixed numbers as improper fractions. So I have 1 4/5 times 2 and 2/9. So I'm going to work around from the bottom, work to the left. I'm going to multiply first and then add. Right? I'm going to do this process on both of these mixed numbers and rename these as improper fractions. So 5 times 1 is 5, 6, 7, 8, 9. I have 9 over 5 for the first mixed number. Then 9 times 2 is 18, 19, 20. And I have 20 over 9 for the second mixed number. Now I'm going to look for opportunities to cancel. And I see an opportunity here where 9 and 9 will cancel down to 1. And 5 and 20 will also cancel because they can both be divided by 5. And when I do that cancellation process and I multiply my numerators, 1 times 4 is 4. My denominators, 1 times 1 is 1. I will rename that as a whole number and get an answer of 4. And then problem 28 is my next problem in this section. Let me make some space on the board for problem 28. And what happens in this problem is I have a decimal and a fraction. And I can't multiply a decimal times a fraction, but I do understand that decimals and fractions are just two different ways of writing the same information. And so I can rename my fraction as a decimal or rename my decimal as a fraction and go from there, right? Now the easiest way is probably going to be to rename my fraction as a decimal. So I've got 7.35 times negative 2 point, because I've got a whole number, so that's my 2, and then the 6/7, the fractional part, is going to become a decimal. And I'm going to turn that fraction into a decimal by saying my numerator divided by my denominator. 7 can't go into 6, so I have to annex a 0, add a decimal point and annex a 0. And 7 times 8 is 56. I'll subtract and get 4. Bring down that 0. 7 times 5 is 35, and I'll subtract and get 4 and bring a 0. And you can see that that's just going to keep repeating that 5. So I can just round that off to 0.86 and then multiply these two decimals together. 7.35 times 2.86. And of course this one is a negative, but I'm going to start with my hundredths place. 6 times 5 is 30. Write my 0, carry the 3. 6 times 3 is 18. 19, 20, 21. Write my 1 and carry the 2. 6 times 7, 42. 43, 44. Now I'm going to use 0 as a placeholder and move to tenths place. I'm going to say 8 times 5 is 40. Write my 0, carry the 4. 8 times 3 is 24, 25, 26, 27, 28. Write my 8, carry my 2. 8 times 7 is 56, 57, 58. Use 2 zeros as placeholders and move to my ones place. 2 times 5 is 10. Write my 0, carry my 1. 2 times 3 is 6, and 1 makes 7. And 2 times 7 is 14. I'm going to add my columns. When you are 15, 16, 17, 18, 19, 20, 9, 10, 11, and 2. I have 4 digits after or to the right of the decimal point, so I also want my answer to be formatted the same. I want 4 digits to the right of my decimal point, and I get 21.0210. That last 0 is not necessary for me to write. And so I can just write 21.021 as my decimal answer. And I can't forget that it's going to be negative, because my rules when I multiply are that odd quantities of negative signs in the problem produce a negative answer. And I had one negative symbol, so I have a negative answer. Now, the answer key may have a decimal answer that's just a smidgen different if they did not round to 0.86 like we did. And that can cause just a little bit of a difference, but not enough for it to actually be considered wrong when there's no specific instructions about how you should round the problem. All right, the next section tells us to write the reciprocal for each, and we know that that means we put whole numbers over 1. We take fractions and flip them upside down, and if they're negative, they're still negative, right? And we take mixed numbers like 31C, we have 2 3/4. We rename these as improper fractions, and then we write the reciprocal. So 2 3/4, 4 times 2 is 8, 9, 10, 11 over 4. Flip that before we write the reciprocal. And in problems 33 and 34, we are finding the quotient. So we're doing the very same thing we were doing with the product section, where we're changing changing mixed numbers to improper fractions, and we're changing any decimals to any fractions and decimal problems that are mixed. We're changing the fractions to decimals before we work the problem. However, I don't see that we have any mixed fractions and decimal problems. And then we are applying keep, change, flip. Now let's move to section 5.6 where we're simplifying. And we're going to look at some problems here in this section. We've got problems 36, 39, 40, and 41. I'm going to start with problem 39 because it's more of a complicated problem. Problem 36 is fairly simple. We're following the rules for GIMDAS here. So we're making sure that we do things in the appropriate order because that will affect our answer. So for problem 39, we have 2 2/3 in parentheses. And we are dividing that by 1 1/2. And then we are dividing that answer by what's in the second parentheses, which is 3 1/3, minus 1 1/5. Now, these kind of problems are where it's easy for us to get tripped up because we've got one set of rules in this parentheses where we're adding and subtracting, and another set of rules in this parentheses where we're multiplying or dividing. Okay? And we start with grouping. This is a group and this is a group. I'm going to start with this group here where we see addition and subtraction. And I'm going to rewrite this in a vertical format once more because once I rename with new denominators, if I end up needing to borrow from my whole number in order to make this subtraction actually happen, I need it to be in a vertical format. So I recognize that I can rewrite these as fractions with a denominator of 15. I'll multiply this fraction times 3, and I'll get 3 over 15. And I'll multiply this fraction up here times 5 and get 5 over 15. Now, lucky for us, we have a larger numerator here than we do here, so we're not going to have to borrow. Let's add our whole numbers over here, and we are ready to begin subtracting. So 5 minus 3 gives me 2 over 15, and 3 minus 1 gives me 2. So the answer to this set of parentheses right here, the answer is 2 2/15. I'm just going to write that above the parentheses in a different color ink. That's the answer to this parentheses. Now I need to go back and work on this grouping here. This grouping has division in it. With division and multiplication, I don't have to worry about common denominators. What I do have to do is rename every mixed number as an improper fraction. So when I rename the first mixed number, I'm going to get 8 over 3, and this is going to be divided by 2 times 1 is 2 plus 1, 3 over 2. So I've renamed 2 2/3 as 8 over 3, renamed 1 1/2 as 3 over 2. Now I need to apply keep, change, flip. So I'm going to keep the first fraction, change division to multiplication, and flip the second fraction. All right? Now sometimes we second guess ourselves because in this problem here, we see that there's some cancellation we can do. We can cancel the 3 and the 3 and the 2 and the 8, but we'll be getting a step ahead of ourselves. We've got to flip that second fraction before we try to cancel. And once we flip it, we can see cancellation's not an option now. There's nothing that can be canceled. So we're going to multiply our numerators, 8 times 2, and get 16. Multiply our denominators, 3 times 3, and we'll get 9. So we have 16 over 9. And then we can rename that, but we don't really have to rename it because the next step is going to be division, and I'll just be turning it right back to a mixed number, to an improper fraction again. So I'm going to write 16 over 9 above that first set of parentheses. So now this is what my problem looks like. 16 over 9 divided by 2 and 2/15. And I need to rename this mixed number as an improper fraction. So 15 times 2 is 30, plus 2, 32 over 15. So I have 16 over 9 divided by 32 over 15. And I'm going to keep the first fraction, change division to multiplication, and flip the second fraction. Now I'm going to look for opportunities to cancel. And I see that 16 and 32 can cancel. Both of them are divisible by 16. And 9 and 15 can cancel. They're both divisible by 3. So I've done that cancellation. Now I'm going to multiply. 1 times 5 is 5. 3 times 2 is 6. I have 5 over 6. And I'm going to go back and evaluate. Did I have, in this problem here, was anything negative? No. So I'm going to have a positive answer. I did have a negative fraction here, but I worked with that. I had positive and negative, and so I found the difference of those two, which is how I'm supposed to do that. So I have 5 over 6 as my final answer here.